Okay, I'm Dr. Ed Dene. This is determination of sugar content in a beverage by density. And so we're going to be measuring the sugar content in this Powerade and comparing it to a set of standards that we're going to make up by measuring the density of those standards. So the first thing the procedure says in step 2 is to record the volume of one serving and the amount of sugar in one serving of Powerade. So we're going to look on the nutrition label here. Okay, and you can see off the nutrition label the serving size right there. And then you can see over here how much sugars there is right there. Okay, so that's what we're going to compare it to from our measurements. All right, so now we're going to make up the standards. And to make up the standards, it says to come up with a plan to make up standards using sugar and in a beaker. And it has to be between 3 and 17%. And the manual goes through how to make a 5% solution. So we're going to go ahead and make that, and then let's go ahead and do a 10 and approximately 10 and approximately 15%. That'll give us a good range. Okay, so in order to make up a 5% solution, you would need 5 grams of sugar and 95 grams of water for a total of 100 grams. So that would be 5% sugar. Okay, so if we need 95 grams of water, that's essentially 95 milliliters of water, because the density of water is roughly 1 gram per milliliter, although we're going to measure that as well. But we're not going to we don't need 100 milliliters or 95 milliliters of water. We're going to make roughly half that. So we're going to weigh out about 2.5 grams of sugar, and then we're going to add in roughly 47.5 milliliters of water. Okay, so we got to measure out 2.5 grams of sugar, and for that we're going to use our analytical balance. Okay, and so as you can see here, the balance, this is kind of an unusual balance. It uses a comma instead of a decimal point. Okay, because this was made over in Britain. So this is reading negative 2.991 grams, negative 2.991. Okay, well, obviously there's nothing on it right now, and you can see here there's an air shield, so we're going to lift the air shield up. And you can see on here there's a weigh boat. That weigh boat, the large one, is not touching this air shield. Okay, and it's there basically just to protect the balance pan so we don't spill anything on it. Okay, so I'm going to put the air shield back down. I'm going to zero out the balance by hitting the 0 or tare button here. Okay, and it reads 0.000 grams, so it goes to 3 decimal places. All right, so then what I'm going to do is I want to zero out my beaker. So I'm going to put on my 50 ml beaker. Put the air shield back on. Okay, so the beaker itself weighs that, but we don't care what the beaker weighs. We want to know what the sugar and the water is going to weigh. So we're going to zero out the beaker. Okay, and now I've got to add 2.5 grams of sugar. Okay, but I'm not going to spend a whole lot of time trying to get to the exactly 2.5 grams. I'm just going to get close. Okay, and I'm going to try to not miss the beaker here when I'm doing this. There's that. Okay, that was pretty good. Put that back on. All right, so 2.508 grams. Okay, now what I'm going to also then do is add 47 milliliters of water, 47.5, and I'm going to measure that using a graduated cylinder. Okay. This is deionized water, and I'm going to try to get roughly 47.5, but it doesn't. The actual amount doesn't matter because we're going to actually record the weight, the total weight. So as long as we're close, we'll be close. So I'm going to add this. Now usually you don't want to use a lot of liquids near a balance, but we're going to make an exception in this case, so we're going to be very careful to make sure the water does not get into on the balance. So we're just going to add that, like so. And we will mix it up, but we don't have to mix it up right away because we want to get a weight first. So I'm going to put the air shield back on. And so 48.422 grams. Okay, so that's the first one. And then I'm going to stir that up with a glass stir rod to make sure everything is dissolved. And well mixed. Luckily, sugar dissolves relatively quickly, so this won't take too long. Try not to spill anything. Okay. So that's one down, two more to go. Okay, so now we're ready to weigh out number two. I've already zeroed my balance. I'm going to put the beaker on here. All right. As you can tell, the beaker doesn't weigh the exact same, but again, we're not worrying about that because we're going to zero it out. Okay, so let me put the air shield on and re-zero. Okay, so this time, in order to make a 10% solution, I need to roughly 5 grams of sugar in here. Close, but get a little closer. But the exact amount doesn't really matter as long as we record it. It's close enough because we're just trying to get roughly 10%. So let me put the air shield back on. Okay, so that's the weight of the sugar in sample number 2 here. And then we're going to add 45 milliliters of water to this one. Oop, over. Try that again. As you can see, I'm reading it at eye level, which is roughly what we want to do. All right, so that's 45 milliliters. And let's add that carefully. Okay, put the air shield back on. Okay, so that's the total mass of solution number 2. All right, so we're going to go ahead, I'm just going to set that one aside, and we're going to go ahead and make solution number 3 here at the same before we stir those up. So I'm going to put beaker 3 on here. Again, it's off a little bit, but we're going to re-zero that because the beakers all weigh a little bit differently. And this time, we're going to put 7.5 grams of sugar. And so this one. So this one's our super sugary solution. time. That's okay. Okay, so that's the weight of the sugar in solution 3. And now I'm going to add 42.5 milliliters of water. Okay, so again, let me measure that. All right. Okay. And there you go. That's the total mass of solution number 3. And you can see the last digit moves around a little bit because there's always a little bit of uncertainty in that last digit. Okay, so now all I have to do is stir these up, and then we'll be ready to measure the density. Okay, so in order to measure the density, we're going to use a 10 milliliter pipette. Okay, and so the idea here, as you can see, it's a 10 ml pipette right on the side. There is a little line here that you may or may not be able to get on the video. Okay, so what this line does is if I have water where the meniscus, the bottom of the meniscus is right on that line, and I let it drain out, it'll give me exactly 10.00 milliliters. So we'll know the volume exactly. Okay, but there's a special technique to using these pipettes. Okay, we need the pipette and we need a rubber bulb. Okay, and I'm going to use, I grab the rubber bulb in my dominant hand, which for me is my right hand, and I hold the pipette up near the top with my left hand. Okay, and I'm going to draw up the solution through the tip above the line, and then I'm going to remove the bulb, put my finger on the top. You can either use your forefinger or you can use your thumb. I like to use my forefinger. And then I'll slowly let it down to the line, okay, watching it at eye level, and then I'll transfer it and let it drain out to get the exact measurement. All right, so now we're going to first, we've got a clean, dry 50 milliliter beaker. And again, we're going to put that on the balance, and we are going to zero out the balance with the beaker, because again, we're not worrying about the weight of the beaker here. Just going to do that again. All right, so it's zeroed out. What we're going to measure first is deionized water, and so in this beaker here, I just have some deionized water. Okay, and so I'm going to pipette from here, and I'm going to set it down over here so that way you can see what I'm doing, hopefully. Okay, yeah, take that lid off, and we'll just save that step. All right, so I've got this up here. Now, in order to do this, there's a couple of different things. One, you want to squeeze the bulb first before you put it on here, because if you don't, you squeeze the bulb, you end up blowing bubbles, and we don't really need that. Doesn't matter so much for water, but for other things, we wouldn't want to do that. So you squeeze the bulb first. Now, to make a good seal, you'd say, okay, push down with this hand. But if I do that, I'm going to put a lot of pressure on that tip, and there's not going to be any way for the liquid to come up. So you don't want to push down with this hand, you want to lift with your pipette hand. Hold this hand steady. So you hold this steady, and you lift up with that hand to make a good seal. Now the other thing you have to worry about is you don't want the tip of your pipette coming out of the level of the liquid while you're going, because then you'll draw air into the bottom, and the liquid that's already in the pipette will shoot up into the bulb. Okay, and so the best way to do that, of course, is if you have a lot of liquid here, that prevents that. But you want to be lifting up with this, but you don't want to lift it too high and the tip come out of the liquid. So I always stick that in there, and I judge kind of where my top hand has to be, and this hand does not move up, just this hand. So I do that, and you can see there I'm drawing up the liquid, and I go all the way above the line, and then I put my finger on the top. Okay, now I made that look really easy. It is not that easy. Okay, Now, I have to let the level, which is way up here, down to the line. Now, in order to do that, I have to get down at eye level to see the line. And one way to do that, I tend to just lighten my finger here. I don't lift off. If I lift all the way off, it drops too far. So I just lighten the pressure, and then I turn this, rotate it a little bit, which breaks the seal enough to let this down. But I got to get down at eye level here. And see, I'm letting it out drop by drop. And I get to the bottom of the meniscus like so. Then I'm going to transfer it over here. And as I'm letting it out, I want to have the tip resting against the side of the beaker. We just let this drain out. And that'll get me exactly 10.00 milliliters, so I'll know the volume exactly. And obviously the balance will tell me how much it weighs. Okay, now, you see when I'm done, there's still a little bit of liquid in the tip. That's designed to be that way. So you do not blow this out.
I've lost it. There it is. Okay.
There it is. Okay. All right. So now we're going to put the air shield back on to get a reading of the mass. So there's the reading of the mass. Okay. So now, that's one data point. We can calculate the density from the mass divided by the 10.00 milliliters. But we're going to want to get 3 sets of data. So I'm going to just tear this out. Okay. So now it's 0. And now I'm going to essentially repeat the steps. So I'm going to pipette a second 10 milliliters. Okay, so obviously I'm going a little faster here because I'm not showing you all the steps. So that is the mass of the second 10 milliliter portion that we added, because we zeroed it after the first 10 milliliter portion. Okay, again, repeat it again for the third one. Zero it out, and pipette a third one. There you go. That's the mass of the third 10 milliliter portion. All right, so we've got 3 for the deionized water. Okay, so I'm going to take that out. Now, we just have to measure the density of our 3 solutions that we made. Okay, so we're now going to measure the density of our 3 standard solutions. So I've got 3 more beakers here. So again, I'm going to put the first beaker onto the balance. And again, it has a different weight, so I'm going to just tear it out, zero it out. Okay, and now I'm going to measure the density of solution number 1, okay, which was our roughly 5% sugar solution. Okay, Okay. Now, in order to do that, I'm going to use the same pipette, but since there's a little bit of water in the pipette still from the previous one, I need to rinse this with the solution and discard it before I actually start making measurements. So I'm going to just take the cover off here. And so in order to rinse the pipette, I'm going to draw up some of the solution, and I'm going to just twirl it around to coat it. Okay, so I brought up some solution, and just coating it with that solution, and I'm going to discard that. Okay, because we have plenty of solution 1, and now the little bit that's left in here is solution 1. So now I'm going to go ahead and pipette and get the density here. Get the mass. So that's the mass reading for the first 10 mil portion of solution number 1. As you can see, it's a little higher than the pure water. Zero it out. And we're going to do this one 3 times as well. Now, I'm making this pipetting look really easy. Partially is because, let's say I've done this thousands of times, and if you're watching this video, I would strongly suggest practicing doing some of this pipetting before a lab exam or something like that. Oh, gotta get the weight here. So that's the weight of the second 10 mil portion. Again, I'm going to zero it out. There's the weight of that one. That was 3, right? Okay. So that's it for solution number 1. So now I'm going to do solution 2, separate, clean, dry beaker. As I zero it here, and move this one out of the way, just so I don't mess up. Okay. Now again, I've got to rinse the pipette with now solution 2. Right. there's the mass of the first portion of solution 2. Again, we're going to zero it out. Add a second 10 milliliters. There's the weight of the second 10 mil portion. Whoop, forgot I got to zero it first. I guess I wouldn't need the air shield unnecessarily for that. Now I'm back at the third. Okay, so from each of these, we'll have a mass, we have a volume, you can calculate a density, and then you can calculate the average density for each of the standards. We also, since we have the mass of the sugar and the mass of the water, we can calculate what the actual mass percent sugar is. And those are the two variables that you're going to plot to make your calibration curve. So there's the weight of the third 10 mil portion of solution number 2. Okay, so there's 2. One more to go of the standards. Again, I've got to rinse the pipette. So now you should be asking yourself, is the mass of this one going to be bigger or less than the ones for the first 2 standards? There's the weight of the first 10 mil portion. Okay, I'm going to zero that out and repeat twice more. Oh, now I went under the line there, so what I'm going to do with that is I just have to draw it up again. Okay, so I didn't quite get above the line there, or went down below the line. That happens. There's the mass of the second 10 mil portion. Zero that out. There's the mass of the third 10 mil portion. Now I'm going to show you one other thing here about this one. Right, we added 30 milliliters, but if you look, it's not exactly on the 30 mil line on the beaker. Of course, the reason for that is of course beakers are not a very good measuring tool for measuring volume. That's why we're using the pipette. All right, so now we've got our three standards measured. And so now it's time to measure our unknown, our Powerade. And we're going to compare it to what's on the label and see if that's correct. So again, I've got another 50 milliliter beaker, which is 0. Okay. And I'm going to pipette directly out of the bottle, okay, which is one of the things we do not actually consume anything that's been in the lab, so I'm not going to worry about contaminating it or any of that kind of thing because we're not going to consume it. All right, but again, I'm going to have to rinse my pipette with the Powerade. So maybe you'll see it a little better here what I'm doing. So, and then I'm rotating it a little bit here to coat the whole inside, and then I'm just gonna get rid of that bit. And you can tell there is a lot of sugar in here. Okay, so I got some bubbles in there, so I'm just gonna. Oh, okay, the bubbles broke up. All right. So now you can see that's in the tip is orange colored, so it's now Powerade. So I don't have to worry about having any of the other solution in there. All right, 10 milliliters Powerade. Okay, so this one might be a little harder to read. Well, harder for you, maybe easier for me to see the line here in this case. All right. Okay, so 10.198 mass of the first portion. Again, we're going to measure this 3 times. Okay, there's the mass of the second 10 mil portion. Zero that out. portion. Okay, so that should be enough. That should be all the data you need. And now you just need to do the data analysis as described in the lab manual.